The vast expanse of our solar system is a dynamic and ever-changing environment, where celestial bodies interact in ways that often defy our understanding. Among the most intriguing of these interactions are collisions, events that can reshape planets, moons, and other objects in profound ways. Recently, astronomers and scientists have observed something extraordinary. A massive object appears to have collided with Neptune, the eighth and farthest known planet from the Sun. This event has sent shockwaves through the scientific community, raising questions about the nature of the object, the impact on Neptune, and the broader implications for our understanding of the solar system. Neptune, a gas giant known for its striking blue hue and fierce winds, is no stranger to cosmic encounters. Its moons, rings, and atmosphere have long been subjects of study, revealing a complex and dynamic world. However, the recent collision is unprecedented in scale, prompting scientists to scramble for answers. What was the object that struck Neptune? How did it affect the planet's atmosphere, rings, and moons? And what does this event tell us about the potential for similar collisions in the future? In this article, we will delve into the details of this monumental event, exploring the observations made by astronomers, the theories proposed by scientists, and the potential consequences for Neptune and the solar system at large. We will also examine the broader context of cosmic collisions, from the formation of the solar system to the present day, and consider what this event means for our understanding of planetary science and the risks posed by such encounters. The discovery of the collision. The first signs of the collision were detected by astronomers using a combination of ground-based telescopes and space observatories. On insert date, a team of researchers noticed an unusual disturbance in Neptune's atmosphere. Bright, localized spots appeared in the planet's typically smooth and uniform cloud cover, suggesting a sudden and significant event. These spots were accompanied by changes in the planet's infrared signature, indicating a release of energy consistent with a high-velocity impact. Further observations revealed additional clues. The Hubble Space Telescope captured images of a faint debris trail near Neptune, while radio telescopes detected unusual emissions from the planet's vicinity. These findings pointed to the possibility of a collision, but the nature of the object remained unclear. Was it a comet, an asteroid, or something else entirely? To answer this question, scientists turned to computer simulations and historical data. By analyzing the trajectory and energy of the impact, they estimated the size and speed of the object. Preliminary results suggested that the object was several kilometers in diameter, large enough to cause significant damage but small enough to have gone unnoticed until the moment of impact. The object's speed, estimated at tens of kilometers per second, indicated that it originated from the outer reaches of the solar system, possibly the Kuiper belt or the scattered disk. The impact on Neptune. The collision had immediate and dramatic effects on Neptune. The most visible consequence was the formation of a large, dark spot in the planet's atmosphere. Similar to the Great Dark Spot observed by the Voyager 2 spacecraft in 1989, this new feature was likely caused by the disruption of Neptune's upper cloud layers. The impact released immense amounts of energy, heating the surrounding atmosphere and creating shockwaves that propagated across the planet. In addition to the atmospheric changes, the collision may have affected Neptune's rings and moons. The planet's faint ring system, composed of dust and small particles, could have been disturbed by the debris from the impact. Some scientists speculate that the collision may have created new rings or altered the orbits of existing ones. Neptune's moons, particularly those closest to the impact site, may have experienced gravitational perturbations or even secondary impacts from ejected material. One of the most significant concerns is the long-term impact on Neptune's atmosphere. The planet's weather systems are driven by internal heat and the absorption of sunlight, and a large-scale disruption could alter these dynamics. Scientists are closely monitoring changes in wind patterns, cloud formations, and temperature gradients to assess the full extent of the damage. Theories about the object. The identity of the object that collided with Neptune remains a subject of intense debate. Several theories have been proposed, each with its own implications for our understanding of the solar system. Comet. One possibility is that the object was a comet, a icy body originating from the Kuiper belt or the Oort cloud. Comets are known to have highly elliptical orbits, bringing them close to the Sun and the inner planets before returning to the outer solar system. A comet striking Neptune would release large amounts of water ice and other volatiles, potentially explaining the atmospheric changes observed. Asteroid. Another theory suggests that the object was an asteroid, a rocky or metallic body from the asteroid belt or the scattered disk. Asteroids are typically smaller and denser than comets, and their impacts can release significant amounts of energy. If the object was an asteroid, it could have penetrated deeper into Neptune's atmosphere, causing more severe damage. Interstellar object. Some scientists have raised the possibility that the object was not from our solar system at all. In recent years, astronomers have discovered several interstellar objects passing through our solar system, such as Oumuamua and Borisov. If the object that struck Neptune was interstellar, it would provide valuable insights into the composition and dynamics of objects from other star systems. Fragment of a larger body. Another intriguing theory is that the object was a fragment of a larger body that broke apart due to gravitational forces or a previous collision. This could explain the object's size and speed, as well as the presence of a debris trail. Broader implications. The collision with Neptune has far-reaching implications for our understanding of the solar system and the risks posed by cosmic impacts. Here are some key points to consider. Frequency of collisions. While collisions between large objects and planets are rare, they are not unheard of. The most famous example is the impact that led to the extinction of the dinosaurs 66 million years ago. The Neptune event serves as a reminder that such collisions can still occur, even in the outer solar system. Planetary defense. The detection and tracking of potentially hazardous objects is a critical area of research. The Neptune collision highlights the need for improved monitoring systems, particularly for objects in the outer solar system that are difficult to observe. Atmospheric dynamics. Studying the aftermath of the collision provides valuable data on the behavior of planetary atmospheres under extreme conditions. This information can be applied to other gas giants, such as Jupiter and Saturn, as well as exoplanets in distant star systems. Formation of the solar system. Collisions played a key role in the formation and evolution of the solar system. By analyzing the debris from the Neptune impact, scientists can gain insights into the processes that shape the planets and other celestial bodies. Potential for life. While Neptune itself is unlikely to harbor life, the collision raises questions about the potential for life on other planets and moons. Impacts can deliver organic materials and create environments conducive to life, as seen on Earth and potentially on Europa and Enceladus. Conclusion. The collision with Neptune is a stark reminder of the dynamic and sometimes violent nature of our solar system. As scientists continue to study this event, they will uncover new insights into the processes that shape planets, the risks posed by cosmic impacts, and the broader context of our place in the universe. While the full consequences of the collision remain to be seen, one thing is certain: the universe is full of surprises, and we have much to learn from events like this. In the coming months and years, astronomers will keep a close eye on Neptune, monitoring its atmosphere, rings, and moons for signs of further changes. The data collected will not only enhance our understanding of this distant world but also inform our efforts to protect Earth from similar threats. As we gaze into the depths of space, we are reminded of the fragility of our planet and the importance of exploring and understanding the cosmos. The recent discovery of a massive collision on Neptune has sent shockwaves through the scientific community. Observations from ground-based telescopes and space observatories have revealed unusual atmospheric disturbances on the ice giant, suggesting that a large object, possibly a comet or asteroid, slammed into the planet. The impact has left a noticeable scar in Neptune's atmosphere, and scientists are now racing to understand the implications of this event. Neptune, the eighth planet from the Sun, is no stranger to cosmic collisions. Its turbulent atmosphere, characterized by supersonic winds and massive storms, has long fascinated astronomers. However, the scale of this recent event is unprecedented in modern observations. The collision is believed to have released an enormous amount of energy, creating shockwaves that rippled through the planet's upper atmosphere. This has resulted in the formation of a dark spot, similar to the famous Great Dark Spot observed by the Voyager 2 spacecraft in 1989, but significantly larger and more intense. Scientists are particularly concerned about the long-term effects of this collision. Neptune's atmosphere is composed primarily of hydrogen, helium, and methane, with trace amounts of other gases. The impact could have disrupted the delicate balance of these gases, potentially altering the planet's climate and weather patterns. Additionally, the collision may have ejected a significant amount of debris into space, which could pose a threat to nearby moons or even future space missions. One of the most pressing questions is the nature of the object that collided with Neptune. Early estimates suggest it could have been a comet or asteroid several kilometers in diameter. Such an object would have been traveling at incredible speeds, releasing energy equivalent to millions of nuclear bombs upon impact. Understanding the composition and trajectory of the object could provide valuable insights into the dynamics of the outer solar system and the frequency of such catastrophic events. The discovery has also reignited discussions about planetary defense. While Earth is relatively well protected by its atmosphere, which burns up smaller objects before they can reach the surface, Neptune's thin atmosphere offers little resistance to incoming projectiles. This event serves as a stark reminder of the potential dangers posed by near-Earth objects, NEOs, and the importance of monitoring and mitigating such threats. In the coming weeks and months, astronomers will continue to monitor Neptune closely, using advanced instruments like the James Webb Space Telescope to gather more data. These observations will help scientists better understand the aftermath of the collision and its implications for Neptune's atmosphere and moons. Additionally, the event provides a unique opportunity to study the effects of large impacts on gas giants, which could shed light on the formation and evolution of our solar system. While the collision with Neptune is a rare and dramatic event, it underscores the dynamic and ever-changing nature of our universe. As scientists work to unravel the mysteries of this cosmic encounter, the rest of us are left in awe of the sheer power and unpredictability of the cosmos. The universe, it seems, still has many surprises in store.